If you've spent any time evaluating ClickHouse, you've almost certainly heard one of these. ClickHouse can't delete data. ClickHouse is immutable. It's append-only. Deletes mean heavy, painful mutations. Here's the thing. That used to be a fair warning. In 2018, it was basically true, but it's now 2026, and that advice is older than some of the databases people are comparing ClickHouse against. Over the last 8 years, ClickHouse's delete system was rebuilt across 5 distinct eras and more than 80 merged pull requests. So today, we're going to walk the actual commit history, not marketing slides, and see exactly how and when every one of those criticisms stopped being true. First, let's be fair to the critics, because the reputation didn't come from nowhere. ClickHouse was built on a simple idea. Analytical data is like logs. You write it once and you read it a million times. That design choice is exactly why ClickHouse is so fast at scans. And early on, the only way to delete was a command called alter table delete, which was deliberately heavyweight. The syntax itself was a signal. This is an admin operation. Don't treat me like a transactional database. So when people said avoid deletes in ClickHouse back then, they were right. The problem is that the warning got frozen in time while the engineering kept moving. Competitors found it a convenient story to repeat. Let's check the receipts. Here are the 6 claims you'll still hear in 2026. ClickHouse can't delete. It's immutable and append-only. Deletes require heavy mutations. ReplacingMergeTree can't handle deletes. You need the experimental lightweight delete flag. And final is too slow to use in production. Every one of these has an expiration date in the changelog. I'm going to give you the specific version and the specific PR where each one became false. Let's go era by era. Era 1, 2018. ClickHouse ships alter table delete as a mutation. Mechanically, when you deleted even a single row, ClickHouse found every data part containing a matching row and rewrote it, reading the old data, dropping the deleted rows, and writing a brand new part. The catch is the cost. ClickHouse stores each column in its own file, so on a 100-column table, deleting one row meant reading and rewriting all 100-column files for that part. The cost scaled with how wide your table was, not with how many rows you actually deleted. That's the real source of deletes are expensive, and honestly, for that era the criticism was accurate. This was the only delete path for 4 years. Era 2, 2022, version 22.8. This is the big one. Pull request 37893 introduces standard SQL delete from and completely reframes what a delete is. Instead of rewrite every affected part, the new model is flip a bit, hard link the rest, and filter on read. Every part gets a hidden column called row exists. When you delete a row, ClickHouse just sets that row's bit to 0. The data is still on disk, only the mask changed. Then on every query, ClickHouse quietly injects a pre-where on that mask, so deleted rows get filtered out before it even reads your real columns. And because the mask is tiny, it can skip entire blocks of data that are fully deleted. The numbers from the PR itself, on a 100 million row table, 15 single row deletes that took about 8 seconds as a heavy mutation now took about 200 milliseconds, roughly 40 times faster, and that's just the initial write. Era 3, 2023, version 23.3. Lightweight delete graduates. It's on by default. Production ready. This is also the moment to kill one specific piece of FUD. People still say you need allow experimental lightweight delete. You don't. In June 2023, PR 544 renamed that setting to enable lightweight delete and turned it on by default. The old name still works as an alias, purely for backward compatibility, but it hasn't been required in 3 years. This era also made deletes synchronous by default, so the command doesn't return until the rows are actually gone from query results, and it added operator tools, like the ability to force physical cleanup on demand for compliance use cases. So if someone tells you to set that experimental flag, they're describing a release that no longer exists. Era 4, 2024. This one closes the most legitimate complaint about lightweight delete. Okay, but the deleted rows just sit there taking up disk space. Early on that was kind of true. The parts still held the masked rows until a merge cleaned them up, and the merge scheduler was counting physical rows, so a giant part that was 90% deleted might never get picked for cleanup. PR 58223 fixed exactly that. The scheduler now counts existing rows, not physical rows, so that 50 gigabyte part that's 90% deleted, it's now treated as a 5 gigabyte part, it gets merged, and the dead rows actually disappear. This era also added partition scope deletes, so you can say delete from in partition and skip scanning everything else, plus full observability through the system tables. Era 5, 2025 into 2026. Even lightweight delete still wrote something to disk per delete. So for workloads doing tons of tiny frequent deletes, version 25.7 introduced patch parts. Now a delete is basically a tiny insert. You write a small patch that says mark these rows deleted, it's applied on read, and it folds into the data on the next merge. No part rewrite at all. ClickHouse's own benchmarks claim up to 1,000 times faster than classic mutations for small selective changes. That's a vendor number on a favorable workload, so treat it as an upper bound. But the mechanism is real. And this era also fixed the last big surprise. With on-the-fly mutations, a delete you just issued is visible to your very next query, even before the background work finishes. Now, row-by-row delete isn't even always the right tool. If you're clearing out a whole day or a whole customer and your data is partitioned that way, drop partition is the answer. It's atomic, it's safe across replicas, and it's essentially instant regardless of data size. And for upsert style workloads, ClickHouse has ReplacingMergeTree with an isDeleted column. So ReplacingMergeTree can't delete is just wrong. You insert a tombstone row and the engine drops it on merge. Pair that with the final keyword for consistent reads. Yes, final used to be slow. That critique had teeth a few years ago. It's been heavily optimized since and is now the recommended way to get immediate consistency at query time. So step back and look at the whole arc. 2018, deletes exist, but they're heavy. 2022, lightweight delete flips the model. 2023, it's GA and on by default. 2024, storage reclaims space intelligently. 2025 and 26, patch parts make deletes nearly free and they're instantly visible. 8 years, 5 errors, 80 plus pull requests. Every claim on that myth slide maps to a specific version where it died. Quick practical guide, bulk cleanup on a partition boundary, use drop partition, selective row deletes, plain delete from, it's lightweight by default, high frequency small deletes, turn on patch parts, upserts with deletions, replacing merge tree plus final. And for guaranteed physical removal compliance like GDPR erasure, the heavyweight mutation is still your friend because it promises the bytes are actually gone when it finishes. The point is, you've got the right tool for each shape. So next time someone tells you ClickHouse can't delete, here's your move. Ask what version they tested. If they're citing the experimental flag, they're pre-23.3. If they're saying heavy mutations only, they're pre-22.8. If they're saying deleted rows linger forever, they're pre-2024. If they're benchmarking 21.x or quoting a 2018 blog post, they're not evaluating ClickHouse. They're evaluating a system that doesn't exist anymore. The commit history doesn't lie. 4 production-grade delete paths, lightweight by default, patch parts, on-the-fly visibility, full observability. ClickHouse's delete engine in 2026 looks nothing like the one that earned those early warnings. So don't take my word for it, and definitely don't take a competitor's. Test it on your workload. That's the only benchmark that matters. If this was useful, the full PR by PR write-up is linked below. Thanks for watching.